are at least two different ways to think about it, right? Relative price of non-traded to traded goods, it could change because of changes in demand, or it could change because of changes in supply, right? Everything is supply and demand. So if there are shocks to demand, preference changes, and so on, that could be one source of changes in the relative price. Alternatively, there could be shocks from the supply side, and those are typically what we think of as technology shocks. Okay? So we measure them by changes in labor productivity or total factor productivity. Now, if you think about traded goods and non-traded goods, so traded goods are things like computers, shoes, clothes, cars. Non-traded goods are services, right? Healthcare, education, and so on. If you think about productivity growth, which sector do you think productivity growth would tend to be faster than the other? Do you expect equal productivity growth in services and traded goods? We expect productivity to be faster in the traded goods sector, right? So if you think about manufacturing, right, our efficiency in manufacturing in the last 50 years has increased enormously, right? The machines have become much more sophisticated, supply chains have become much better, right? China is the world's manufacturing center now, extremely efficient supply chain, and so on. But if you think about services, productivity has grown in services also, but not nearly as fast. Right? If you think about healthcare, right, 50 years ago, one doctor could see 10 patients in 1 hour. Okay? Now, maybe with making appointments online, etc., you have some changes, maybe 12 patients an hour now. But the difference is not so big compared to before. Okay? One surgeon, if he could perform one operation 10 years ago, today also the same one operation, or maybe 1.5 operations. So growth tends to be, productivity growth or technology growth tends to be more concentrated in the traded goods sector relative to the non-traded goods sector. So if this happens, that productivity grows much faster in the traded goods sector compared to the non-traded goods sector, what will happen to the relative price of non-traded to traded goods?
Non-traded goods become more expensive.
Non-traded goods will become more expensive, right? Productivity grows faster in the traded goods sector, so the cost of production of traded goods relatively lower compared to non-traded goods. So non-traded goods, their relative price will rise because productivity growth is concentrated most in the tradable goods sector. Okay, so the Harrod, Balassa, Samuelson model is saying that, well, changes in the relative price of non-traded to traded goods, they are driven by different trends in productivity in the tradable and non-tradable industries. Okay, so the productivity trends are not the same in these two sectors. And because productivity is evolving differently in tradable and non-tradable industries, that changes the relative price of non-traded to traded goods. And that in turn changes the real exchange rate in the long run. Okay, so that is the mechanism that underpins the Balassa-Samuelson model, and we're going to look at this in more detail now. So So I'm going to look at this paper, which examines the relationship between the relative price of non-traded goods and total factor productivity in the traded and non-traded goods sectors. So so we've seen that the relative price of non-traded to traded goods is an important relative price for an open economy. It's a key component of the real exchange rate. Like real exchange rate is the home relative price minus the foreign relative price. So now, many studies have shown that the relative price of non-traded to traded goods has a unit root. Okay? So then the question arises, what is the cause of this unit root? And this unit root is being translated to the real exchange rate. Okay? So here we hypothesize, well, shocks to technology are well known to have high persistence. They are natural candidates for explaining the stochastic trend in the relative price of non-traded to traded goods. Okay, so if preferences are relatively stable, people's preferences are not changing too much, okay, and technologies in the tradable and non-tradable industries have different stochastic trends, they are evolving differently, then that will create a stochastic trend or a unit root in the relative price of non-traded goods. And the purpose of this paper is to see whether really the stochastic trend in technologies can explain the stochastic trend in the relative price of non-traded to traded goods. Okay, so you can read this literature review and so on. So I'm going to jump into the model now. So suppose we have an open economy with two sectors. Good T is tradable, good N is non-tradable. Both goods are produced via Cobb-Douglas production functions. So that is the production side. Each sector so this is the Harrod-Balassa-Samuelson model. So be careful about the notation. So in the previous paper, alpha was the share of non-tradables prices in the overall price index. Here, alpha is the share of labor in production. Okay, so that's the production. So we can think of A as the total factor productivity. L is labor, K is capital. Now, we make some assumptions here. Because firms maximize profits, there is perfect competition in each sector, so both tradables and non-tradables. Okay? Maybe a strong assumption. Tradables generally are more competitive than the services sector. But here we are assuming both sectors are perfectly competitive. Capital is perfectly mobile internationally. Okay, so there are no barriers to capital mobility. Again, this does not apply to all countries. And for most developed countries, this is a reasonable assumption to make. But for developing countries like India, China, don't have perfect capital mobility. Then there is perfect domestic factor mobility. That means both labor and capital are free to move inside the country between tradable and non-tradable sectors. Okay, so these assumptions give us a set of first order conditions. Okay, so let's derive these. So the marginal product of capital in the traded goods sector that's the derivative of output with respect to capital in the traded goods sector. So that's going to be so I'm differentiating this with respect to K. So 1 minus alpha, I don't change anything here, and then this one disappears because I get a minus 1 over here. So I'm just left with this. So I'm going to write this as where small kt is the capital labor ratio in the traded goods sector. So that's my notation. Okay. Likewise, in the non-traded goods sector, marginal product of capital is going to be something similar. 1 minus alpha n a n sorry, I don't know. So same equation in the other sector as well. Okay, the only difference is now in this model, the tradable good we will model as the numerator. Okay, so we're going to express everything in terms of the tradable good. So here the marginal product that's already in for the traded goods, so this already in terms of tradables. But here this marginal product is in terms of the non-tradable good. So we have to convert this, to compare this and this, we have to convert it into tradables. And to convert this into tradables, I have to multiply this by Q, where Q is the relative price of non-traded to traded goods. Okay, so I multiply this by Q to convert this marginal product into tradables so I can compare. So that gives me my first set of first order conditions. Both these marginal products of capital, they should equal what? marginal product of capital should equal wages? No. That's marginal product of labor, right?
Oh, right.
So
Right.
rent, right? Rent, or the cost of capital is the real interest rate. We measure that by the real interest rate. So the marginal product of capital in each sector, because capital is mobile across sectors, so these two marginal products should be the same, right, in both sectors. If capital is more productive in the tradable sector, then it's going to move until the marginal product is equalized across sectors. So this is the first set of conditions. The marginal product of capital in the traded goods sector and in the non-traded goods sector, they should both equal the real interest rate. Okay? Now this real interest rate R is determined in the world capital markets, because we are assuming capital is perfectly mobile internationally. Okay? No single country can determine the world real interest rate, so each country takes this real interest rate as exogenously given. Okay? Exogenously given. So we are assuming each country is too small to dominate the world capital markets, and they take the real interest rate as given. So that's our first set of conditions. Next, we're going to look at the other input, which is labor. So look at the marginal product of labor. In the traded goods sector, so that's this. So that's this. Is that correct? So something like this for the traded goods sector. Then in the non-traded goods sector, change all the T subscripts to N, but again we have to remember the traded good is the numeraire good, so to convert this in terms of tradables, we multiply it by Q. So then our second set of conditions is we are going to equate both these marginal products we're going to equate both these marginal products to the real wage rate. To the real wage rate W, because labor can move from one sector to the other. In equilibrium, the marginal product of labor in both sectors should equal the real wage rate in terms of tradables. So W is the real wage rate in terms of tradables. So now we are going to solve this model, it's good to keep track of what are the things that we know and what we are trying to find out. Okay? So what are we trying to find out? Okay, I'm sorry, I made a mistake here. This should be small k, not big K. So that's the capital labor ratio. Okay. Yeah, this is correct. Small k. Okay, so here, what are the things that we know and what are the things that we don't know? So, our main variable of interest is Q. That is the relative price of non-traded to traded goods. We want to see how this is related to technology in the two sectors. Okay, that's the main purpose. So Q is something we want to find out. Then the capital labor ratios and the wage rate, the real wage, these are all endogenous. So we want to determine these variables within the model. The world real interest rate, as well as the technology shocks in the two sectors, these are exogenous. Okay, so we are assuming the country is small enough that it cannot influence the world real interest rate. It takes the world real interest rate as given. And of course, the technology shocks in both sectors, they are also exogenous. So we're not modeling the evolution of technology. So this we take as given. And of course, the alphas are just the labor share in each sector. That's a parameter of the production function. It's either known or it can be estimated. So basically, given these variables, we have to solve for these four. Okay? And as it turns out, we have four first order conditions, right? 1, 2, 3, and 4. So 4 equations, 4 unknowns. So that should be quite easy, right? With a little bit of algebra, you can solve for these 4 endogenous variables in terms of these exogenous variables. So let's I'm not going to do that. I'll just tell you how to do it. So we can start with this equation. Okay. So this part, this marginal product of capital in the traded goods sector, we are equating this to the real interest rate R. Okay. Maybe my handwriting is really bad. So this is the real interest rate, the world real interest rate R. Okay? Now, what is unknown in this equation? What is the endogenous variable here? That's simply the capital labor ratio in the traded goods sector. R is exogenous, AT, the technology, is exogenous. So we start with this equation and we solve for KT in terms of R and AT. Okay? So that's where we're going to start. So let me circle that in red. So this equation allows us to solve for KT. That's the first unknown. Now, once you know what KT is, then you go to this equation. So this equation over here, So now you know KT, this is exogenous, so you can figure out W, the real wage rate. Right? Once you know KT, that allows you to solve for W. So that's the second step. So step 1, and this is step 2. Okay, so now we have solved for KT and W, and we haven't used two equations yet, right? We haven't used this one, and also we haven't used this one over here. And so we have two equations now, and we have two unknowns. The two unknowns are Kn and Q. Okay, so two equations in two unknowns. You know how to solve for that. So you can solve for Kn and Q using the remaining two equations. Okay, so I'm not going to do that in class, but if you have trouble sleeping at night, that's something you can try on your own. Okay. So do that. Just go through the algebra. It's not really very difficult, and I might ask you to do it on the exam. So it's good if you have practiced it before. That might be helpful. Okay, so do that. I'm leaving that as an exercise. Okay, so that's what this is describing. Okay, so we have the marginal product of capital in each sector. That's equated to the world real interest rate, and relation 4 equates marginal product of labor to the real wage rate, and then you can solve for everything. So when you do some algebra, as we discussed, what you can show is the following. Okay? So when you go through the algebra, ultimately you'll be able to show that the log of the relative price of non-traded to traded goods, that's log of Q, is a function of total factor productivity in the traded goods sector minus TFP in the non-traded goods sector plus some function of the world real interest rate. Okay, so that's what we can show. Now, what is the intuition over here? Okay, so we are mainly interested on what impact technological change is going to have on Q. So what we are saying is, well, technological progress generally tends to be concentrated in the traded goods sector. So we expect AT to generally grow at a much faster rate than AN. And suppose AN does not change and AT goes up, that is going to increase the relative price of non-traded to traded goods. Okay? That is the essence of this Balassa-Samuelson hypothesis. Okay? So, of course, when we implement this empirically, we have to be careful about the unit root properties and co-integration, etc. But that's the intuition. Okay, so TFP tends to grow faster in this sector, and as AT grows faster compared to AN, we expect Q to go up as well. Okay, and so as Q goes up, that will appreciate the real exchange rate of the country. Okay, so that's the underlying idea. So now let's think how we can implement this model empirically. So first assumption we are going to make is these two technology processes, AT and AN, they are different stationary, or I1, possibly with non-zero drift. So technology follows a unit root process. Again, this is something you can test. This assumption is testable if we actually test it. Second assumption is log AT and log AN are not co-integrated with each other. Okay? Again, if they are co-integrated with each other, their unit roots will cancel out, and then relative price would not have a unit root, and then real exchange rate would not have a unit root either. Okay? So what we are saying is that basically if log AT and log AN are not co-integrated, it means that technological progress in the traded goods sector does not get transmitted to the non-traded goods sector, even in the long run. Okay? So the two sectors are really different from each other in a fundamental way. Okay? Just because technology is improving in the manufacturing or tradable sector doesn't mean that that improvement in technology will also apply to the non-traded goods sector. Okay? So that's the second assumption. The third assumption is this log of the world real interest rate is a stationary or I0 process. Okay? So what is the justification for these assumptions? Well, the third one is just to make our life easy. Okay? It's hard to measure the world real interest rate, right? So for a single country, you may be able to measure what interest rate is for the world. You take each individual country's nominal rate, then you take a weighted average for all the countries in the world, and you do the same thing for inflation. You subtract that, and that's just too much work and painful. So if you assume it is stationary, then you can just throw it out. It's not going to affect. We know that in a co-integrating regression, anything that is stationary, if you leave it out, that does not affect anything. Okay? So when it's difficult to measure something, and in this paper, the focus is not on the real interest rate, focus is on the technology part. So you just abstract from this, assume this is stationary. Okay? In fact, many macro models also imply the real exchange rate, the real interest rate to be stationary. Right? It's in macro models, this is related to the growth rate of consumption. Right? From the first order conditions, the real interest rate equals the growth rate of consumption, and so the growth rate of consumption cannot be non-stationary. Okay. Consumption can be non-stationary, but not its growth rate. Okay, so here is the justification for these assumptions. So first assumption simply is a necessary condition for technology to explain the unit root in the relative price. Right? If technology does not have a unit root, it cannot explain why relative prices have a unit root. Second assumption tells us that technological progress is not transmitted from one sector to the other, even in the long run. So these, the unit roots in AT and AN will not offset each other. Okay? And we're going to look at the assumption for these two, we're going to look at the evidence for these two assumptions. And then the third assumption, we maintain it for two reasons. First, many economic models predict the real interest rate to be stationary. And second, difficult to construct an accurate proxy for the world real interest rate. Okay, so taken together, what do these three assumptions tell us? Well, they tell us that log of Q, the relative price of non-tradable to tradable goods, should be unit root non-stationary, and it should be co-integrated with the labor share adjusted TFP differential. So log of Q should be co-integrated with this. Okay? So this is a typo. It should be alpha n over alpha t over here, and nothing over here, minus log an. So this part. This part is stationary, so this should be co-integrated with this. So please make that correction. So we define Qn to be this part. Alpha n, maybe I should write this down. Okay, so this is the value of Q predicted by the Balassa-Samuelson model. So M is for model. So the model says Q should equal this. So what we will test, so we do a regression like this. Mu plus gamma Qm plus some error term, and then we want to test that this error term is I0, this error term is stationary. That means Q is co-integrated with this TFP differential in the traded and non-traded goods sectors, and gamma should equal 1. The coefficient gamma should equal 1. Okay, so these are the two testable predictions of this model. So basically we are saying the relative price of non-traded goods should be co-integrated with the TFP differential in the tradable and non-tradable sectors with a coefficient equal to 1. Okay. Is it clear? Any question? Is it okay? Okay, so now we are going to do this in two ways. First, we do it with a single equation method, so single equation unit root, single equation co-integration test, and then we do it with panel unit root and panel co-integration. Okay, so let me skip the econometric methodology. I'll say a few words about data. Okay, so we use industry level data. Okay, so we have different industries, and we are going to combine them into tradable and non-tradable. Okay, so there are many different industries in any economy. Some of them produce tradable output. Some of them produce non-tradable services. So agriculture, manufacturing, mining, and retail and transportation we classify as traded goods. Utilities like electricity, gas, and water, financial services, insurance, real estate, private and government services, we classify them as non-traded goods. Okay, so we use industry level data and then combine them into a traded good and a non-traded good. Then we have to estimate the technology coefficients in each sector, in the tradable and non-tradable sector. So that we construct as a solo residual from a constant price, a domestic currency series, because we have data on output, capital, labor share, and employment. So you can back out the TFP. You know how to do that, right? Maybe it's a standard kind of thing. Okay, so So we have data on output, right? Because we combine different industries into the traded industry. We have output for this in constant prices. We observe employment in the traded sector. Again, it's by combining each industry's employment. We have capital stock in each industry. Again, when we combine, we get capital stock for the traded industry. Okay? Alpha is the share of labor, right? And that's something we don't always observe. So alpha is a parameter and it could be unknown, but under perfect competition, alpha is the share of compensation that goes to labor. Okay, so basic macro, you may have learned something like that. So alpha can also be interpreted as the share of output which goes to labor as compensation for labor services in production. And 1 minus alpha, therefore, is the share of output that goes to non-tradables. So we observe, we can get the value of alpha from there. Okay? So then we know everything in this equation except AT. So you can back out what AT is. Okay? So you can estimate technology in traded and non-traded industries like that. Okay, so properties of the data. So these are unit root tests for TFPs and relative prices. So here we have data for 14 countries. For each country, we are testing whether technology has a unit root in the traded sector, in the non-traded sector, and log of the relative price of non-tradables, whether that has a unit root. And generally speaking, we cannot reject the null hypothesis of a unit root in any of these. So all of them have a unit root. Then the next thing we look at is whether the TFPs in the two sectors, are they co-integrated with each other? Okay? So we mentioned if AT and AN are co-integrated with each other, they will cancel the stochastic trend, and then relative price cannot have a unit root. So here we see, are they really co-integrated with each other? And we cannot find any evidence of co-integration. So this is the null hypothesis of no co-integration, and we cannot reject it. And you can see with 1 or 2 exceptions, we generally don't reject that. So that means TFP is evolving differently in the traded and non-traded goods sectors. They are not co-integrated with each other. And then next, we test the main result. Okay. Now the main thing we are interested is in co-integration between the relative price of non-traded goods and the TFP differential in the traded and non-traded goods sectors. Right? So that's QM, the TFP differential. So here we are testing for co-integration country by country, one country at a time, single equation. And the theory predicts that they should be co-integrated, and this coefficient gamma should be 1. Okay? So what do we find? Well, gamma seems to be all over the place. You can see it's 3 over here, 2, 1.4. For some of the countries, it may be close to 1, like Japan, Netherlands, Sweden. Okay? But for many of them, it's jumping around quite a bit. It's not always close to the predicted value. Here we are testing the null hypothesis of co-integration. Okay? And it's accepted in many cases, but sometimes you can see here it is being rejected. Okay? So when we look at the single equation methods, then the results are not so strong for the Balassa-Samuelson hypothesis. Okay, so you can read the paper. Okay, so there is a large cross-section variation in the value of gamma from a high of 3.25, but if you look at and the low value is 0.16, so large variation. Okay, here we look at the evidence for co-integration, and again, it's not perfect, so it's kind of mixed. You can read the details here. So to get better results, what we now want to do is look at more powerful panel co-integration tests. Okay, so we look at some panel co-integration tests here. These are Cow's and Petroni's tests. These are generalizations of the Dickey-Fuller and augmented Dickey-Fuller test to a panel case. Okay, when we use these, you see that we can easily reject the null hypothesis of no co-integration. All of these we can reject, they are significant. Okay, we can reject the null hypothesis of no co-integration. Second, when you estimate the value of gamma now using panel dynamic OLS or panel weighted dynamic OLS, the value of gamma you can see is much closer to the theoretical value of 1, right? Almost indistinguishable from 1 in many of these. Okay, so using the more powerful panel co-integration tests, we find much stronger evidence in favor of this Balassa-Samuelson hypothesis. And finally, we look at panel unit root test. So panel unit root test imposes a value of 1 on the coefficient, right? So here, this is the relative price of non-tradables. This is the TFP differential implied by the model, and this is the difference between the two. So we are assuming that gamma equals 1, and we impose that here, and we construct the residual. So what we see is log of the relative price of non-tradables, that has a unit root. With the panel unit root test, we cannot reject the null of a unit root. TFP differential has a unit root, but the residual, when we look at the gap between relative price of non-tradables and the TFP differential, that does not have a unit root. We can reject the unit root over there. So that is telling us that the relative price of non-tradables is basically being determined by the TFP differential between the tradable and non-tradable goods. Okay? So to conclude, what are we saying? Okay? What we are saying is different trends in technology in the tradable and non-tradable industries, they create a unit root in the relative price of non-traded to traded goods. And that in turn creates a unit root in the real exchange rate. Right? Earlier today in the first half, we saw real exchange rate is a weighted average of Q in the home country and Q in the foreign country. If Q in each country has a unit root because of different trends in technologies, then the real exchange rate will inherit that same unit root. Okay? So one reason why we observe very persistent deviations from PPP is because technologies evolve differently in the tradable and non-tradable industries. Okay, so that's the bottom line. I have uploaded a set of homework questions on Canvas. So quickly, let me show you. So if you go to Canvas, there is a group homework